Thank you so much, everyone. We are grateful for you. All right. Introductions. Hello, howdy. My name is Brendan Finch. My pronouns are he, him. I taught middle and high school science in Los Angeles for 7 years. I left the classroom in 2014 to build rocketlit.com. So that's a leveled reading website. And we started working on InnerOrbit about 5 or 6 years ago. It's like somewhere around that. The actual inception date is not clear to us. I wrote a lot of the assessments on the site to start with, and right now I am talking to folks in both Texas and in NGSS states to figure out what else we can do to better support students and teachers and administrators with assessments and with data. Really, really excited to be embarking on maybe some new stuff, and maybe we're just going to keep doing what we're doing. Who knows? I also want to share my New Year's. It's not like a resolution. Like I'm not like I'm going to lose 15 piano keys, but I'm endeavoring to play more piano. So I am like real amateur piano player, and I really enjoy it. And so I'm gonna play me some more piano. I'm really excited for Emily to introduce herself as well.
Thank you, Brendan. I also expect you to play a song for me at some point. You've got, what, 50 weeks before the end of the year to make good on your resolution. Hello, everybody. My name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher for 10 years. While I did that, I had the opportunity to teach in our alternative learning program. I taught regular chemistry. I taught honors chemistry. So I had the really cool ability to teach a lot of different kiddos from a lot of different backgrounds and a lot of different ability levels. While I was a teacher, I considered myself to be an NGSS pioneer and advocate in my science department, and now I get to talk about it all day, which makes me super happy. I led a lot of data-driven dialogue as a PLC lead during my time as a teacher as well, and now I have the pleasure of working with districts across the country to help them implement InnerOrbit and learn what we do and how we can best support them. And McDonald's French fries just straight up do not need ketchup. Like, why mess with perfection? We got McDonald's the other night, like my husband and my kids and my husband are just dousing ketchup, and I'm like, something is wrong here. I failed. So just straight up salty goodness.
But there's something about those chemicals they put on there that it does things. It does things. Speaking of doing things, let's talk about what an orbit is, because that does things too. And thank you for introducing yourself, Emily. So really, really quick, we want to introduce the platform so you know what this is and what it's all about. Emily, I'm going to play Jingle Bells for you, and then we'll just knock that one out with 50 weeks left of the year to enjoy other things. Now, I've actually been learning a Mac Miller song. I'm not sure if anyone's familiar with his work. And there's like a really, really pretty, like jazzy album. So I'm learning more of the songs in that album. Anyways, what is InnerOrbit? Let's stay focused here. So InnerOrbit is three things, and then we kind of also do another thing. So first, we provide students and teachers with phenomena. That is a thing that happens in the natural world. You can use science knowledge to explain. And so you can take what you learned in class and apply it to make sense of this new thing. And we're talking about sense making and making sense of stuff and even phenomena later on. Along with those phenomena, we write really targeted questions. We're not just like a bank of like, here's a bunch of questions aligned to standards. These are questions about just the DCI, just the SEP and DCI, just the cross-cutting concept in DCI, all three dimensions. We are very, very targeted and specific about the story that we tell through the questions and through the data that is generated. Speaking of stories, so here's an example of our reports. This is our dimensions report. It's one of the reports that is pulled from as students answer questions on InnerOrbit. And it's a beautiful thing because you can take a look at this data and decide students need help with developing these models at the 6-8 grade level band. And specifically, it's this very discrete element, develop a model to describe unobservable mechanisms where they need support. And so we build all of our content around the idea that we want to tell a story about students, and that story should be a true story. And so we write questions to very discrete parts of these standards so that you can do that. And maybe you're like, okay, so that's cool, Brennan, but I still don't understand these standards well enough, and I need a little bit of help with that. So if that is the case, then please engage us for professional learning. This is not professional learning. We are here to talk about the NGSS, but we also do really targeted sessions that are based on research and often model engaging classroom strategies. We're not doing that today. We're just going to like teach you about the SEPs. And then we also drive those things by teacher feedback. And so if your district or school or classroom, and if you would benefit from having someone deliver some coaching and some PD, we would love to do that, and we do that a lot. If you ever want to meet with us and chat with us about that, or set up a free pilot, I'm going to drop a link in the chat. You can set up a free pilot, or talk to us about any of these things, and we'd love to chat with you about that. But without further ado, we're going to dive into our agenda for today. This is going to be a quick webinar. As you can tell, I'm talking fast, and I usually do, and that's what's going to happen today. So our objective is to introduce and explore the SEP, asking questions and defining problems, and talk about how to properly assess using this SEP in service of sense making. Now, something to note here is that we have two webinars around this SEP. This is the introductory webinar. The webinar on Thursday is the scaffolding webinar. So we're going to take the base that we're laying today and build on that scaffolding, if you will. Anyways, so our session is going to be short. We're going to talk about sense making. We're going to talk about sense making and the practices, and we're going to look at two different criteria for what that is. And we always start everything with sense making. If you don't understand sense making, then nothing else matters. That is the sort of like the foundation for all of the NGSS. And then Emily is going to walk us through some sample questions. And then you all are going to decide whether these questions meet the criteria for sense making. It's going to be really fun and exciting. And so if you're sitting there and you're like, I have a lot of questions, well, we're talking about asking questions, so you are welcome. Anyways, to kick things off, I want to talk first about what sense making is. So sense making is just kind of a very, very core concept to the NGSS. And I want to help you to make sense of that. If you've ever seen us at conferences, literally the back of our shirt says like making sense of sense making, which is silly, but it is true. That's what we want to do here. So all of the content I'm going to go over in these slides is pulled from documents that Achieve put forth. And Achieve is the group of academics and educators and researchers who worked with state partners to write the NGSS. So they were a nonprofit that helped write the NGSS. And so all of these come from this task annotation project for science. So if you're wondering where did these people get these ideas, well, it came from Achieve, who is a big part of the body that wrote the standards for the NGSS. So what is sense making? Well, previously in standards, we would teach students about skills, and we teach them about knowledge, and maybe even like ways of thinking about stuff. So each of those dots can represent ideas, abilities, and experiences that students have developed. And the goal with the NGSS and any three-dimensional standards is that we want students to take a phenomena and make connections between their knowledge, their skills, the ways they look at the world, their experiences, and that phenomena. But that's not all we want them to do. We don't want you to just say, this is how magnetism applies. This is how I can look at a model of that. No, what we want you to do is actually take that phenomena, that problem, and we want to bind together your knowledge, your skills, your ways of thinking about the world. And that's what sense making is intended to be. So we want to say we're learning things in curriculum, and then we want to take that and say, okay, now can you apply that to these other phenomena after you learn those things? And so what sense making is driving towards is for students to be able to think critically about anything in the world. You learn about a few things, and you take that knowledge and you apply it to anything that has to do with those topics that you learn about, and you can make sense of that new thing, because now your knowledge, your skills, your experiences are all connected, and any phenomena that you throw at that, you can make sense of that, or you can start to make sense of that. Great. So that's what sense making is. And that's the big idea, the core of that. But there are these things called practices. And that's one of the driving forces in the NGSS of sense making. So the goal is that we want to push students towards sense making. And each of these practices are ways that you can do that in your classroom. So when we look at sense making and we look at SEPs, we usually think of these as like a 3D performance. So Achieve put out some criteria, and these are two of the criteria that Achieve put out to say if you are using an SEP fully, then you're moving students towards that sense-making experience. And so what we're going to look at here are two of the criteria that Achieve put forth to say, yes, you are using the SEP in service of sense making. That's what we'll say is you're using that SEP for students to make sense of a phenomena. So two of the criteria that we need to have in order for students to be using an SEP, we don't just want to say like model this thing. Well, in fact, they need to do two things. So one, there needs to be a mechanic or skill. They have to do the thing. If they're not asking questions, then they're not hitting the SCP asking questions and defining problems. And second to that, there needs to be a driving purpose. So that purpose, I'm going to clarify these things in future slides, but they need to both use the mechanics of the SCP and have a driving purpose for using the mechanics. Why are they using those mechanics? And if they're doing both of those things, then they are accessing a practice truly, and not just a skill, but a practice. And that's what science is. It's incorporating that knowledge into practice. Okay. What are mechanics and skills? So these are things like procedural features and knowledge pieces. So when it comes to asking questions, these are necessary components. So are students asking questions? Are they differentiating between scientific questions and non-scientific questions? Which color is the best versus which color absorbs more heat energy from sunlight? There's a testable question in there. There's a scientific question, and there's a question that is non-scientific. It's still cool. I mean, the best color is obviously purple, but I can't give you evidence to explain that. Emily disagrees. That's okay. So defining engineering problems is another thing that can be a part of asking questions and defining problems. So can we use empirical evidence in order to answer these questions? Can we identify constraints that may prevent us from being able to do that, or constraints in the design process for this engineering problem? Really, really, really important. So even if we have students differentiating questions, defining problems, those are insufficient evidence of students' use of the SEPs. What we have right now are a whole bunch of independent pieces. And if we ask students to juggle with them, we're gonna end up like our friend here who's throwing these, I think those pumpkins up in the air, and they're just gonna fall around. Like, it's not enough just to say I can define, differentiating questions and define problems. What we want students to have is a driving purpose, and it's obvious that this lady in this GIF has a driving purpose. For what, I'm not sure, but she's doing it. So this is the why of why students are engaging in a practice. And so in order for a practice to be used through the lens of sense making, students need to be grappling with applying their knowledge through the lens of asking questions. So I need to have some knowledge, and then I need to figure out how to apply that through the lens of asking questions. Oftentimes, you're going to see students making connections between previously learned ideals or skills and a new phenomena. So sense making is all about doing things in a new phenomena. I used to have exit slips at the end of my class where we'd literally say, I'm like, here's the model that I gave you today. Identify these two things, describe these things, summarize this process. Like, is this a part of this process? No. So that is not transfer. That is not sense making. That's just regurgitation, memorization. We don't need that anymore. We need making sense of new phenomena. An interesting thing about asking questions and defining problems is that this is going to be used to involve another practice. So usually you're going to be asking questions to refine an investigation. You're going to be asking questions to clarify a model. You're going to be asking questions to get to the core claims of a statement, of an explanation. And so something unique about asking questions and defining problems is oftentimes this SEP is going to be connected to, or almost all the time, to another practice. You're going to be driving that other practice forward, clarifying the problems, the solutions, the claims being made through asking questions and defining problems. All right. In sum, we're looking for both mechanics, skills, and a purpose in order for students to be properly addressing an SEP and for students to be engaging in sense making with that SEP. Now, what does that mean? Well, if students are using mechanics and skills, you're going to see them doing things like asking scientific questions, defining solvable engineering problems. It's a big piece of all the standards is, can you actually solve this? Is this actually scientific? Are these questions relevant to the topic at hand? These are three different criteria we can use to say students are using mechanics and skills. This is not an exhaustive list. There are other things that students might do to exhibit features of the mechanics or skills of asking questions and finding problems. For driving purposes, what we want them to do is take those mechanics and skills and do more with them. They need to use that to design an investigation, to clarify, to evaluate an investigation. They need to use that to analyze and interpret evidence or data. How can I clarify the data that's in here? What are some constraints to that? And then improving a current model or solution. So as you can see, all of these things are different SEPs. And so what we're looking to do is take not just are they doing the thing, but are they then applying it to clarify, to improve something else afterwards. All right. Emily is going to walk us through some sample questions now. We're going to take those two different sort of columns of criteria. We're going to say, all right, do students have a mechanical skill? Can we identify a driving purpose behind these questions? And we're going to do that using some phenomena from InnerOrbit. So what you're going to see in all of these different slides are a bunch of items pulled from InnerOrbit, some of which are supposed to involve the SEP, some of which are not supposed to involve the SEP. And we're going to identify and explain whether or not these match these things. So I'll pass it off to Emily to explain a little bit more and to take us through this next section. But to you, Emily.
Awesome. Thank you, Brendan. So the first question that we're going to look at here is going to be assessing the performance expectation MSPS 2-3. And in this one, the phenomena that students are trying to make sense of is there's this little wound copper wire, tightly wound in sort of a tube, and then we have a magnet that we put, or sorry, a battery that we put magnets on either side of. And then we put that in the tube and it zooms all the way through and it's magical and scientific. So here's our question. What can be done to the wire to increase the strength of the magnetic field it produces? So just as a reminder to what task we're all trying to accomplish here. We are trying to figure out if this assessment item has both mechanics and skills for the SEP, asking questions and defining problems, and if it also has a driving purpose. If this assessment item has both mechanic and skills and purpose, then we know we are properly assessing the SEP, asking questions and defining problems through sense making. So when we're looking at our list of mechanics and skills here, asking scientific questions, defining solvable problems, evaluating questions for relevancy. Students aren't really doing any of these right now. If you look, they're not asking any questions and they're not defining a problem. They're thinking about a potential solution in order to increase the strength. But the key part of this SEP is they actually have to actually define the problem themselves. So they are not using a mechanic or skill in this case. So then do they have a driving purpose? Usually if the first one's a no, the second one's a no. But in this case, we're not necessarily asking questions to design an investigation or look at data or improve a current model or solution in this case. Now, one thing I want to make really clear is, does this mean this is a poor question? No. None of these questions are inherently necessarily poor questions. This question just isn't servicing sense making with the particular SEP we're talking about today. So keeping that in mind, let's look at another assessment item. This is also looking at MSPS 2-3, so the same performance expectation as before. But now our question is this. Refer to the GIF of magnets being pulled into a nice iron slime blob. Which question would be the least helpful in evaluating the factors that affect the strength of the forces seen here? So again, our question is, does this assessment item have both mechanics and skills and purpose? As far as our mechanics and skills go, we have a list of questions here, and students are being asked to identify which one would be the least helpful in evaluating the factors. So in this case, I'm looking at different questions and I'm looking at them and evaluating their relevancy. So which one of these is not going to help me move forward? So in that case, yes, students are using a mechanic or skill in order to answer this question. But remember, they also need to have that driving purpose behind the skill as well in order to truly service sense making. In this case, if you look at that figure 2, they have an experimental setup, they're making observations, and they're running various investigations. So in this case, they're looking to run a new investigation in order to figure out the strength of the forces of the magnets flinging into the blob. And so in this case, they're looking to design an investigation, and so they have a driving purpose, by figuring out which one of these is going to be the least helpful in their investigation. So this one is properly assessing the SEP. All right. Y'all are experts now, obviously. Clearly, that was 5 minutes of perfection. This SEP, I do want to say, was a little bit nuanced. This one I was actually voted for by all of you in order for us to talk about. And there was a lot of nuance that we had in having conversations around this. And so I'm really looking forward to giving you all an opportunity to answer those same questions that I was looking at. So let's look at our first example we're going to try to tackle together. So this one has the performance expectation for PS33. So this is a fourth grade reading question, or fourth grade level question. And this one is all about a barge getting stuck in a canal. I don't know if this, has ever really happened before. So the question that students are trying to answer is, you are investigating how much energy is needed to free the toy barge, replicating the real barge, unfortunately. Which of these questions would help you investigate this? So now we're turning this all back on you. So in the chat, I would love it if you could answer 2 questions for me. Are students using a mechanic or skill in order to answer this question? And do students have one of these driving purposes? So in the chat, if you want to go ahead and write yes, yes, no, no, yes, no, no, yes, some other combination I'm not thinking of, that would be lovely. If you could also in the chat toggle it to everyone rather than just hosts and panelists. It's just like that little blue bar there. Brendan and I would love to see your answers, but in order to get some fun discourse, if everybody sees it, that'll be a little bit more of a conversation starter. So, and bonus points if you want to share why. If you're struggling to answer or why you think what you're thinking, that would be awesome. But in the chat, yes, yes, no, no, yes, no, no, yes. Are students using a mechanic or skill? And do students have a driving purpose? On to all of you. I'll give you a moment to think about it. Oh, this is awesome. Thank y'all. So I'm seeing a lot of yes, yeses. And I do believe I would have to agree with all of you. So are students using mechanic or skill? Yes. They have to be looking at scientific questions here because they have to use evidence in order to answer them. They're looking at the relevancy of them as far as helping them with this investigation. And that investigation right there is our purpose. So trying to actually free this toy barge, investigating how we can do that. So awesome job, everybody. Let's go ahead and do another one.
And just to add on to this, just like a little bit of editorial. So this is a fourth grade standard. And I think a lot of times it's really tempting as a former high school and middle school teacher to evaluate things and say, like, this isn't rigorous enough to actually be a question. Well, this is actually totally developmentally appropriate for a fourth grade student to be going through and asking questions and predicting outcomes. And like that's the idea here. So I think just a really, really important thing to look at when you're like going through these questions is to say, like, is this development appropriate? And we're going to talk about that in the next webinar on Thursday. So we'll send a link for you to RSVP for that at the end of this, and check your email as well. But just something to note is like, think about what grade level this is intended for and decide as far as like that driving purpose and those mechanics skills, is that development appropriate? And then go both ways. You can ask things that are too high or too low. All right, back to you, Emily.
Thank you so much, Brendan. I think it's a really interesting thing, especially when we service 3 through 12 with InnerOrbit, how we can expand and detract what students can and should be able to do at different points. So this one is a middle school one. So now we're leveling up a little bit, MSESS 3.5. This one is looking at a graph about the rate of deforestation in the Amazon forest, as well as looking at global carbon dioxide emissions. So which of these solutions would help to reduce the impact of deforestation? So y'all did awesome on the last one. Same spiel here. If y'all can give a yes, yes, no, no, yes, no, no, yes. Do you think students are using a mechanic or skill to answer this question? And do you think they have a driving purpose? We'll give y'all a moment to think about it.
Answers came a little bit faster on that first one, a little bit slower this time.
I am loving the no yeses. I'd love to chat about that a little bit more. Okay, so are students using one of these mechanics or skills? It seems for the most part, we're all in agreement that the answer is no in this case. So we're not asking questions, we're not coming up with a problem. Okay, so the question itself is the problem of deforestation, but students aren't defining that solvable problem themselves. As far as the purpose goes, you're going to see a no pop up on our screen. And the reason for that is because we're thinking about that SEP of asking questions and defining problems. So there's not a purpose behind that particular SEP, but absolutely there is a purpose behind this question because students are looking for that other SEP of designing investigations and looking for solutions. So in terms of the SCP we're talking about today, I would maybe say a no, just because this is not asking questions or defining problems. But this question could totally be useful and applied with another SCP instead in helping measure success in that way. Awesome. All right. Brendan, should we do one or two more? What do you think? One more? Okay. Why don't you skip on to the next one just to have some fun discourse and go to high school here. So this one is high school. So notice we've got some more info here for the high school level one. HSL is 3-1. Our question is, which of the following questions is answered by the evidence provided in the figures and text? Now, I know y'all are going to be tempted to read the text and figure out the answer to the question. For the sake of your time and ours, withhold that urge. Just ask yourself, does this assessment item, in order to answer it, would students have to use this mechanic or skill? And do they have a driving purpose? So in order to answer the question, you don't have to answer it. In order to answer, what would they have to do? All right. So the reason I wanted to do this one was again to kind of have a conversation around it. So are students using one of these mechanics or skills? Yeah, no. I saw a mix of answers. And when Brendan and I were trying to analyze this question ourselves, we also felt a tug and a pull in either way. In this case, these questions that are listed are scientific questions that need to be answered through evidence found in the figures and text. And so students aren't necessarily asking these questions, they're not generating themselves, but they do need to see if they are scientific questions that can be answered by evidence. But like, does that really fit into this idea of asking questions? We weren't totally sure. We were like, is this more of like a reading comprehension question using science? There was kind of a mixture here. But we agreed with all of you as well that there is not a driving purpose. We're not looking at this idea of mice and obesity and brown fat in terms of like an investigation or data or improving a current solution or model. And so again, is this inherently a poor question? No. But if you're wanting to give students specific practice around this SEP and truly assess if they know it or not, this question may not be the best fit in that circumstance. It was so lovely to have you all today. I'll pass it over to Brendan here to wrap us up, and we'll get you all on your merry way.
Thanks, y'all. Thank you very much, Emily, for going through all of that. And thank you all for your questions. I know someone asked if we had other examples of these charts. So if you head over to our YouTube channel, which I'm going to link in the description or in the chat, you can see what that looks like. And we'd also love to support you if you're curious about how InnerOrbit works in this context. You can find a time on our calendar. I'll drop that link in the chat as well. And then if you want to explore InnerOrbit on your own, but you're like, I don't want to talk to these people, they don't seem helpful, then you can also do that. You can click on that link to start a pilot on your own and explore on your own. We have another webinar coming up, as we previously mentioned, on Thursday, and we'd love for you to sign up for that if you have not already. I'm going to drop that link also into the chat. And if you don't follow us on social, YouTube is the platform where we're posting the most content. It's a great place to subscribe or follow. And then you can also email us at any time with any questions that you have about anything. Thank you all so much for being here. We're very grateful for your time, and I hope you have a beautiful rest of your day. Stay safe, everyone.